Apply properties of real numbers. And obviously, if you've already, since you will have done your notes, your title will already be there, but I just have to put it down every time because obviously otherwise I have no idea what it goes with. Okay, so this is probably one of my least favorite sections of the year just because it's annoying to have to write out the reason that we do everything. We did it by division, we did it by addition, but we got to get through it. I guess at least they're starting us out with it, and then we don't have to worry about it anymore after that.
Wait, do we turn this in? What we're running down? Okay.
Just the homework part afterwards. All right, so number 12. These say to identify the property that the statement illustrates. So we have the different properties. We have closure, commutative, associative, identity, inverse, and distributive. So those are kind of the options that we're looking at here. So this one is 15 times 1 equals 15. So based on your notes, which one would that be? Yep, identity, because we're multiplying by 1. And if you want to abbreviate it as ID and then prop of multiplication, because technically this is the identity property of multiplication, I don't mind you abbreviating it. Just be careful with abbreviations and make sure that you're not writing anything bad when you abbreviate something. 16... We've got in parentheses 6 times 5, close the parentheses, times 7 is equal to 6 times, go away, 6 times 5 times 7 in parentheses. Do you remember how to turn this thing off so it's off? Okay. Stop trying to give me the answers. Which property would this one be? Yep. So associative property of multiplication. Sometimes instead of even writing multiplication, I'll just write an X as the multiplication symbol.
So do we have to write out property of?
Yep, because there's different ones for multiplication and addition. So those ones are just state the property. The next ones are going to be ones where it tells us to use properties and the definitions of operations, so addition, subtraction, things like that, to show that the statement is true and justify each step. So essentially we're going to have a left side equal to the right side, but they're going to look different, okay? And we're going to work the left side down to make it ultimately look like the right side. And we're going to explain why we can do each step as we do it. Okay, and there's things that you're going to be like, why do I have to write that out? It's annoying, I know. There's things that in a lot of cases we would switch, or you'd be like, I don't need to rewrite it this way, but we'll have to do every single step for these problems. Okay, so 18, I've got 15 times, in parentheses, 3 divided by b is equal to 45 divided by b. Now, in a lot of cases, the first thing that people want to do is tell me, well, 15 times 3 is 45, and then I've got 45 divided by b, and I'm done. Wrong. We are not done. Okay? There's a lot of steps. This actually has 4 steps that we have to do to get to our final answer. Okay, so division is not technically a mathematical operation. We're multiplying by an inverse. Okay, so the first thing that I'm going to redo is rewrite this division of 3 divided by b as 3 times 1 over b. So I have 15 times, in parentheses, 3 times 1 over b. And then my reason for that is the definition of division. So we leave the right side alone. So a lot of times I'll just write my reason under there so I'm not tempted to go attempt to do something on that side. Now, I need to ultimately get to 45 divided by b. So the next thing is people still go, oh, well, I'll just go ahead and multiply 15 times 3. I can't do that yet. It's not grouped. Grouping symbols say that the stuff in parentheses has to be done first. So I'm going to regroup it. So I'm going to end up with 15 times 3 in parentheses, and then times 1 over b. What allows me to do that step from there to there? We did it in 16.
Associative property multiplication.
Yep. Associative property, I'm just going to do with an x multiplication. That looks like my variable x. Let's do that. Now I can go ahead and multiply what's in this parentheses. So I've got 45 times 1 over b. And this is just multiplication happening here. I ultimately want it as 45 divided by b, so now I'm going to switch this back to 45 divided by b, and that's going to again be the definition of division. So a lot of people will then say, when we're done with the problem, they'll go back and they'll say, well, why couldn't I have just gone ahead and moved the parentheses to be 15 times 3 and then divided by b? Well, we don't have an associative property of division. We only have it of multiplication. So we have to switch it to a multiplication property before we can do anything else. Okay, so when we get to this point, we would be done. Questions on that one? Like I said, this is my absolute least favorite thing to do, teach. This is hands down the worst question on the quiz and the test for the first chapter is one like this. So,
Isn't it
but
basically like a proof?
pretty much. But what I'm going to tell you is, if you've done them all in the book, I'm not making them up myself. The only thing I might do is change a number, but I'm not going to change the whole problem. So if you've done them all, you'll be fine. 22, another one of these, actually, well, I'm going to do them out of order, but I'm going to do 22 first. In parentheses, 12b plus 15, close the parentheses, minus 3b equals 15 plus 9b. So much like division is not a technical mathematical operation, and you're probably like, well, then why have I ever done division in my life? Subtraction is also not technically a mathematical operation, okay? We are adding an inverse, okay? So I have to change that because, again, I don't have properties of subtraction. I have properties of addition. So very similar to what we did in the previous problem, I need to first and foremost rewrite this minus 3b. So I'm going to keep the 12b plus 15, and then I'm going to say plus, in parentheses, negative 3b. And notice instead of it now being minus 3b, it's plus a negative. Okay, that's changing it. That's doing the inverse of it. And so the reason that I can do that is the definition of subtraction. And if you just want to do like the little symbols to abbreviate and not have to write the whole thing, I'm okay with that. So now ultimately I'm going to 15 plus 9b. So looking at this, I see that things are out of order, right? I have a b term here, I've got a b term over here, and then I've got the number that I want in front in the middle. So I need to do something to swap these two. So that's going to give me 15 plus 12b plus negative 3b. What allows me to swap within a parentheses? Nope, that allows me to swap parentheses altogether. What allows me to swap within it?
Commutative property?
Yep, commutative property of addition. Again, I'm kind of abbreviating here with symbols. Now we can do what Abby said. I need to switch and take, technically this negative 3b obviously isn't really in a parentheses, but these two things over here are grouped. I want to group the things that are like terms, so I'm going to switch and say that this is 15 plus parentheses 12b plus a negative 3b. To use the associative property of addition. And then finally, I can now combine this over here, and so I get 15 plus 9b, and our reason for that is just combine like terms. So basically when I'm grading one of these on like the quiz or the test, obviously on a quiz it's not worth as many points as like a test question is worth, but and you'll also find that my tests in this are very different than your geometry test. It's not like, you know, there's a lot more partial credit involved in algebra than geometry just because of how it works out. But essentially, if you get, like, say you got all the steps right, but you got the reasonings wrong, okay, or you forgot to put the reasons or something like that. If you have the steps right where you, like, swapped the terms where they were supposed to, you rewrote subtraction, you rewrote division, and you just have the reasons wrong, you're still going to get, like, half the credit or maybe even more. Okay, it's kind of like each thing is a point in and of itself. It doesn't necessarily break down to that on a quiz per se, just because this question might be a 5-point question. Well, that's basically, there's 4 steps. So if you attempt it, you get a point, and then it's kind of like each step is 1. But I will give some. I very rarely do like decimal points in these classes just because of the way it breaks down. Geometry, obviously, we have that a decent amount. So just kind of be aware of that. But this will probably be the hardest question on the whole quiz. Historically, no matter how many times I tell people, if you do all the problems in the book, you'll be fine. People still don't do it and still have a hard time. So, anyways, you have all the odd ones available to you, and if you want the even ones, I can give you the other even one that we're not doing as well. 19. So I am doing an odd one just because I want us to see this particular thing here. So I've got in parentheses c minus 3 plus 3 is equal to c. So I don't know why I just threw a random parentheses over here on the side. Okay. So based on kind of what we did in the last one, what do you think should be my very first thing that I do?
Change c plus negative 3.
Yep. So I'm going to rewrite this as c plus a negative 3. And then plus 3. And what allows me to do that?
Definition of subtraction.
Yep, definition of subtraction. Any ideas on what I should do now? Think about what I'm trying to get to.
Regroup it to like c plus in parentheses -3 plus 3.
Yep, exactly. So we've got now, I'm going to regroup c plus and then parentheses -3 plus 3. What allows me to do that?
Combine the terms.
Not yet.
Commutative. Associative.
Yep. Anytime we're totally moving the parentheses, it's associative. If I'm swapping things within it, it's commutative. So this is associative property of addition. All right, now what would my next step be?
Combine. We'll just add.
Yeah, so I'm basically just adding these two things together. So I'm going to end up with c plus 0. Don't just write c. It's c plus 0. Okay, you can, well, technically, I would take a couple different phrasings here. You could say combine like terms. You could say addition. Or you could actually use the inverse property. Okay, so there are a couple times, that's why I like to do this one, where the reason there might be like two or three different phrasings that are fine. So I might have one thing written down like on my key, and then you might have a different reason like on yours, but it still be correct. So just be aware of that. So technically this would be the inverse property, but if you wrote combined like terms or something like that, I would take it as well, because I can see that as well.
But we can also write addition.
Yeah, or you can just write addition, because we're literally just adding. Just make sure that we don't just get rid of that. Make sure we write 0 there when we do that. And then ultimately, now I can go to saying that my answer is C, which is where I was headed towards to begin with. And what allows me to do that?
It's 0,
Identity.
Yep. So this is the identity of addition. Okay, the identity of multiplication is multiplying anything by 1. For addition, it is adding 0 to anything. Questions on any of that? All right, like I said, those are hands down the worst ones. I would say almost all year, but last year's class would have told me that trig was the worst, so, you know. All right, jumping down a little bit, we are doing some unit analysis, which every year I think that people have already done stuff like this in science, and then they're like, we never did that. So I don't know if you've done this or not, but basically we have a little word problem. So 28, you buy 6 gallons of juice, which I'd always love to know what somebody is doing that for. 6 gallons of juice at $1.25 per gallon. What is your total cost? All right, so basically we have 6 gallons of juice. It's getting blurry. And then I have a rate, okay, $1.25 per gallon. So I'm going to set this up. I set it up as like a little T-chart, and I'm going to do this because as we get to a harder problem here in just a second, you're going to see why I like it this way. When we get to the harder one in a second, you're going to definitely want a calculator, but
Oh, can I go get mine on my
you can get it when we're done. I'll just multiply it out for y'all in that one. But when you do the one in the problems, you'll probably want it. All right, so I have 6 gallons, and then I do what we call a T-chart, okay? This is what you would typically do in science when you're multiplying stuff and you're canceling units. When you get to chemistry, especially, this is often what ends up happening. So we have 6 gallons, and then I have $1.25 per gallon. I want to know what my total cost is. That means that's going to be in dollars, right? So I need gallons to cancel. So that means that my $1.25 is going on top. And it's per gallon. That means 1 gallon. So I'm just going to put 1 gallon on the bottom. The unit analysis says then that I can cancel gallons, okay, just like I can cancel other things. Like if I had a 6 on top and a 2 on the bottom, I'd reduce that to 3. It's kind of the same thing. Our units have to cancel as well. So now I have anything that's on the top gets multiplied, anything on the bottom gets divided. So what I really have right now is 6 times $1.25 divided by 1. Okay, so what's $1.25 times 6?
$7.50.
Yep. $7.50. So that would be my total cost for 6 gallons of juice. They must be having a party.
So you just do apple.
In what world
So
is it that cheap, bro?
So it'd just be 6 over 1 times $1.25.
Yeah, you don't really have to. Well, this is my rate. So this is my dollars per gallon. So it'd be the same thing like if we were doing like gas or something like that. It's kind of the same deal. So, or like miles per gallon, you might have that, which we'll have one like that in a second.
Is the teacher like required, or can we just like do the math out like decide on that?
You can, but just make sure you have work shown. And when we get to the harder ones, you're probably going to want to do this. All right, 30. You ride a train for 175 miles at an average speed of 50 miles per hour. I'm just going to put MPH. Trust that y'all have seen a road sign by this point in your life. How many hours does the trip take? All right, so I want to know how many hours it takes. I have the how far I'm going, and I have the speed at which I'm going in miles per hour. So I'm going to start with the 175 for miles on the top of my T-chart. Now, the reason I like the T-chart is it's really helpful to make sure that you have your units correct, okay? Because the temptation here is for people to come up here and stick 50 up here. But it's 50 miles per hour. That would mean miles are on top, hours are on the bottom. I'd end up with miles squared per hour. Okay, that doesn't work. So that means that my 50 has to go down here. 50 miles per 1 hour. So the rate, it's just a fraction. It can be flipped however we need it for it to cancel. And so then I would have 175 divided by 50. Anybody know what that is? Yep. So 3.5 hours. So again, my units canceled. I'm left with hours, which is what I wanted it in. Now, there's some other conversions here. You probably did conversions in elementary school, or hopefully you did, but there are some that you are going to know what the conversion factor is, and there are some that you will not. I'll try to talk through a few of them. They may have been in your notes, I don't remember, but 34, we want to convert 5 hours to minutes. So again, I like a T-chart for this. If you want to do it a different way, that's fine. But I've got 5 hours, and then how many minutes are in an hour? 60. I want minutes, so that means I want that on top. So I've got 60 minutes in 1 hour down here. So then hours cancel. I have 5 times 60. So that would be 300 minutes. Now, just because I'm always mind blown with how many people don't know this, how many seconds are in an hour?
3,600.
3,600. I taught my third grade nephew that 2 years ago. I was like, you're going to know this, how many seconds are in an hour, because so many people don't know that, and it's so useful. Not that you can't ever just multiply 60 times 60, but it drives me crazy when people don't know it. So
6 times 6 is 36, and then add 2 zeros.
correct. Most people don't understand that concept. I'm glad that y'all do, though.
The zeros confuse me. I feel like I'm always not adding enough or adding too extra.
I know. I'm always anytime there's stuff with zeros, I'm like, okay, multiply the regular numbers, and then I'm like, all right, now tack on the zeros, and then I'm counting the zeros. I'm like, I do that with scientific notation too. I'm like, all right, let's just review a couple things. How many quarts are in a gallon?
4.
4. How many cups are in a pint? 2 cups in a pint. How many pints in a quart?
6.
Is that one?
2. Yep. I had to do all these this summer making pickles. How many ounces are in a pound?
660.
How many ounces are in a ton? Or not, wait, yeah.
Whoa.
No,
Whoa.
sorry, not ounces. How many pounds are in a ton?
2,000.
Okay, there we go. I was like, wait, that was not the right word. You both need those conversions
I feel like-
for one of your problems. That's ounces to tons. That's why I said it. And then I was like, wait, that's not what I was trying to ask them. If you get stuck on something like grams to kilograms, that's 1,000.
Is there 8 cups in a gallon or 8 cups in a quart?
So there's 2 cups in a pint, 2 pints in a quart. So there'd be 4 cups in a quart. And so there would be 16 in a gallon. I had to do all these conversions this summer. So I'm like, I was like sitting there and like I had a recipe that was like 4.5 pounds of sugar. And I'm like, can you give it to me in cups? Like, is there another option? All right, last one. 42. Convert the rate into the given units. So this one, they give us 6 feet per second. And they want us to convert it to miles per hour. So again, I'm going to start with the T-chart because this one is going to be longer now because we talked about the other factor. It won't be that much longer, but so I'm going to start with my 6 feet per second per 1 second. Anytime I have a rate, I'm going to want to list it out. Now I'm going to miles per hour. So let's get rid of feet and get to miles. How many feet are in a mile?
5,280.
Yep, 5,280 in 1 mile. And then now, so what this does is this tells me, okay, feet cancel. I'm in miles, so I have that unit correct. Now I need to get to hours, okay? So you can either know how many seconds are in an hour. Why we talked about that one. Or if you don't, then you can convert seconds to minutes, minutes to hours, and you can do it the longer way. But since we already talked about it, I'm going to go ahead and say it's 3,600 seconds in 1 hour. So now unit analysis, seconds cancel, I'm left with miles and hours. So what we would do is we would multiply across the top. So I'm going to end up with, I'm just going to write it over here so we can see it. 6 times 3,600 and then divided by 5,280. And just for the sake of time, that is equal to 4.1 miles per hour. You can always just do MPH when we're doing miles per hour if you would like. That's fine. Questions on that? All right, problems. I think you'll have time to finish them, but it might be close. 13, 17, 21, 27, 35, 37, and 41. And then you'll need to watch 1.2 notes for tomorrow. So you should be able to hopefully knock these out now and then go from there. We're just going to say that y'all have the top box because I don't really foresee Bible needing one a whole lot. And they can just share with you if they need one. So.